Hello everyone, welcome back to another session of Core Java tutorials. I am Dr. Sudharani, professor in the Department of Computer Science and Engineering. Today, I'll demonstrate a Java program that shows the concept of inheritance and runtime polymorphism through a menu-driven application to calculate the area of two-dimension shapes. Polymorphism means many forms. In Java, polymorphism allows objects to behave differently based on their data type or class. This helps in achieving code reusability, flexibility, and dynamic method execution. So this program is all about creating an abstract class named shape, which declares an abstract method called calculate area. This method doesn't have a body because the actual logic of calculating area depends on the specific shape like a circle or a square. We have two subclasses. Circle extends a shape and overrides the calculate area method to return the area using the formula pi into radius squared. Square also extends a shape and overrides the method to return side into side. There are two types of polymorphisms in Java. The first one is compile time polymorphism, which is called as static binding. This is achieved using method overloading. The decision which method to call is made at compile time. Same method name with different parameters in the same class, that is called as compile time polymorphism. Runtime polymorphism, also called as dynamic binding, is achieved using method overriding. The decision is made at runtime. Method is redefined in the subclass with the same signature as in the parent class. Supported using inheritance and upcasting. So this is runtime polymorphism. The difference between method overloading and method overriding is that method overloading same method name, different parameters, overriding same method name and parameters also are same. So this occurs like method overloading occurs in the same class, method overriding occurs in two classes in inheritance. Now in the shape calculator class, we use a menu based interface to let users interactively choose which shapes area to compute. When the user enters 1, they are prompted to enter the radius. The program creates a circle object and calls its calculate area method. Similarly, choosing option 2 asks for the side of the square and calculates its area. If an invalid choice is entered, the program displays invalid choice. Invalid choice means it is not 1 or 2, it is negative values or it is more than 3, 4, 5, 6, etc. If the user chooses option 3, the program terminates. This is a great example of runtime polymorphism where the decision of which calculate area method to execute is made during program execution based on the object type. By designing this way, we achieve flexibility, code reusability, and scalability, allowing us to easily add more shapes in the future by just extending the shape class. Okay, option 2 is area of a square. Option 3 is exit. And then we are writing one more system.out.print enter option and reading the option in the option variable. After reading the option, we are passing this into the switch, and inside switch we are having case 1 and case 2 and case 3 and one default. In the case 1, we are asking the user to enter the radius. Radius is of double type, and then we are creating an object of circle. Instead of saying circle is equal to new circle, Here we are saying shape circle is equal to new circle. Why we are actually doing this? We are actually doing this so that we want to execute the polymorphism through the reference type of the parent class. You want polymorphism and generality, you need to say shape circle is equal to new circle. Here you are storing the circle object in a shape reference. You can only access methods that are defined in the shape and have been overridden in the circle class. This is polymorphism in action. The actual object circle is a subtype, but the reference type is the interface, which is the shape. Similarly, we are doing the same thing for the square shape. Okay, right. So coming back to the differences between method overloading and method overriding. So method overloading return type can be different. So it is insignificant in overloading. Return type is insignificant. But in overriding, return type must be the same. And coming to the access modifiers, for methods which are overloaded, there is no restriction on the access modifiers. But in method overriding, you cannot change the visibility of the method in the overridden class. So it should be same or it should be higher, but it should not be less. Coming to the static methods being overloaded and overridden, so static methods can be overloaded, but static methods cannot be overridden. So to summarize all that we have learned today in this program, so polymorphism comes from Greek language. Poly means many, morph means forms. So it means many forms. There are two types of polymorphism, compile time and runtime polymorphism. Why polymorphism is useful? So polymorphism is useful to do code reusability. Write general code for a superclass and use it for all its subclasses. Extensibility, add a new subclass without changing the existing code. Maintainability, easy to modify or upgrade without touching too much code. And flexible architecture allows interface based programming and dependency. Real life examples of polymorphism can be like in the TV remotes, you will have a button which is play button. So when you what different things does this play button do? It will play music, it will play audio, it will also start a game. So the same button is doing different functionalities. So this is polymorphism in real life. I hope this video is helpful to you. Thank you for watching.